In computer networking, a wireless access point is a device that allows wireless devices to connect to a wired network using Wi-Fi, or related standards. The AP usually connects to a router as a standalone device, but it can also be an integral component of the router itself. Introduction. Prior to wireless networks, setting up a computer network in a business, home or school often required running many cables through walls and ceilings in order to deliver network access to all of the network-enabled devices in the building. With the creation of the wireless access point, network users are now able to add devices that access the network with few or no cables. An AP normally connects directly to a wired Ethernet connection, and the AP then provides wireless connections using radio frequency links for other devices to utilize that wired connection. Most APs support the connection of multiple wireless devices to one wired connection. Modern APs are built to support a standard for sending and receiving data using these radio frequencies. Those standards, and the frequencies they use, are defined by the IEEE. Most APs use IEEE 802.11 standards. Common AP applications. Typical corporate use involves attaching several APs to a wired network and then providing wireless access to the office LAN. The wireless access points are managed by a WLAN controller which handles automatic adjustments to RF power, channels, authentication, and security. Furthermore, controllers can be combined to form a wireless mobility group to allow inter-controller roaming. The controllers can be part of a mobility domain to allow clients access throughout large or regional office locations. This saves the client's time and administrator's overhead because it can automatically reassociate or re-authenticate. A hotspot is a common public application of APs, where wireless clients can connect to the Internet without regard for the particular networks to which they have attached for the moment. The concept has become common in large cities, where a combination of coffeehouses, libraries, as well as privately owned open access points, allow clients to stay more or less continuously connected to the Internet, while moving around. A collection of connected hotspots can be referred to as a lily pad network. APs are commonly used in home wireless networks. Home networks generally have only one AP to connect all the computers in a home. Most are wireless routers, meaning converged devices that include the AP, a router, and, often, an Ethernet switch. Many also include a broadband modem. In places where most homes have their own AP within range of the neighbor's AP, it's possible for technically savvy people to turn off their encryption and set up a wireless community network, creating an intra-city communication network, although this does not negate the requirement for a wired network. An AP may also act as the network's arbitrator, negotiating when each nearby client device can transmit. However, the vast majority of currently installed IEEE 802.11 networks do not implement this, using a distributed pseudo-random algorithm called CSMACA instead. Wireless access point versus ad hoc network. Some people confuse wireless access points with wireless ad hoc networks. An ad hoc network uses a connection between two or more devices without using a wireless access point. The devices communicate directly when in range. An ad hoc network is used in situations such as a quick data exchange or a multiplayer LAN game because setup is easy and does not require an access point. Due to its peer-to-peer layout, ad hoc connections are similar to Bluetooth ones and are generally not recommended for a permanent installation. Internet access via ad hoc networks, using features like Windows Internet connection sharing, may work well with a small number of devices that are close to each other, but ad hoc networks don't scale well. Internet traffic will converge to the nodes with direct Internet connection, potentially congesting these nodes. For Internet-enabled nodes, access points have a clear advantage, with the possibility of having multiple access points connected by a wired LAN. Limitations: One IEEE 802.11 AP can typically communicate with 30 client systems located within a radius of 103 am. However, the actual range of communication can vary significantly, depending on such variables as indoor or outdoor placement, height above ground, nearby obstructions, other electronic devices that might actively interfere with the signal by broadcasting on the same frequency, type of antenna, the current weather, operating radio frequency, and the power output of devices. Network designers can extend the range of APs through the use of repeaters and reflectors, which can bounce or amplify radio signals that ordinarily would go unreceived. In experimental conditions, wireless networking has operated over distances of several hundred kilometers. Most jurisdictions have only a limited number of frequencies legally available for use by wireless networks. Usually, adjacent WAPs will use different frequencies to communicate with their clients in order to avoid interference between the two nearby systems. Wireless devices can listen for data traffic on other frequencies, and can rapidly switch from one frequency to another to achieve better reception. However, the limited number of frequencies becomes problematic in crowded downtown areas with tall buildings using multiple WAPs. In such an environment, signal overlap becomes an issue causing interference, which results in signal droppage and data errors. Wireless networking lags wired networking in terms of increasing bandwidth and throughput. While high-density 256 QAM modulation, 3-antenna wireless devices for the consumer market can reach sustained real-world speeds of some 214 Mbps at 13 m behind two standing walls depending on their nature and C or 316 Mbps at 10 m line of sight or 318 Mbps at 2 m line of sight or 20 to 25 Mbps at 2 m line of sight. Wired hardware of similar cost reaches somewhat less than 1000 Mbps up to specified distance of 100 m with twisted pair cabling. One impediment to increasing the speed of wireless communications comes from Wi-Fi's use of a shared communications medium, thus, two stations in infrastructure mode that are communicating with each other even over the same AP must have each and every frame transmitted twice, from the sender to the AP, then from the AP to the receiver. This approximately halves the effective bandwidth, so an AP is only able to use somewhat less than half the actual over-the-air rate for data throughput. Thus a typical 54 Mbps wireless connection actually carries TCP/IP data at 20 to 25 Mbps. Users of legacy wired networks expect faster speeds, and people using wireless connections keenly want to see the wireless networks catch up. By 2012, 802.11n-based access points and client devices have already taken a fair share of the marketplace, and with the finalization of the 802.11n standard in 2009, inherent problems integrating products from different vendors are less prevalent. Security. Wireless access has special security considerations. Many wired networks base the security on physical access control, trusting all the users on the local network. But if wireless access points are connected to the network, anybody within range of the AP can attach to the network. The most common solution is wireless traffic encryption. Modern access points come with built-in encryption. The first-generation encryption scheme WEP proved easy to crack. The second and third-generation schemes, WPA and WPA2, are considered secure if a strong enough password or passphrase is used. Some WAPs support hotspot-style authentication using Radius and other authentication servers. Some people say the net benefits of open Wi-Fi without passwords outweigh the risks. Other people say that every wireless access point should be locked down with a password. Specialized APs. Industrial-grade APs are rugged, with a metal cover and a DIN rail mount. During operations they can tolerate a wide temperature range, high humidity and exposure to water, dust, and oil. Wireless security includes WPA-PSK, WPA2, IEEE 802.1x radius, WDS, WEP, TKIP, and CCMP encryption. Unlike some home consumer models, industrial wireless access points can also act as a bridge, router, or a client. See also, Wireless Ad-Hoc Network, a decentralized type of wireless network. Wi-Fi Direct, a Wi-Fi standard that enables devices to connect with each other without requiring a wireless access point and to communicate at typical Wi-Fi speeds. Wireless LAN, networks consisting of one or more access points plus one or more devices. Femtocell, a local area base station using cellular network standards such as UMTS, rather than Wi-Fi. List of wireless router firmware projects. LWAPP, Lightweight Access Point Protocol used to manage a large set of WAPs, Wi-Fi array system of multiple APs, WiMAX, Wide Area Wireless Standard that has a few elements in common with Wi-Fi. References